Okay, welcome everybody. Thank you for joining us today for our webinar titled The Environmental Health Impacts of Wildfires and Associated Toxins. We're really excited because we have an amazing lineup of speakers for you. But first, we want to take care of a couple logistics. And so today we have live interpretation. So if you can please look for the interpretation button on your Zoom console and choose your language so that you can hear in the language of your choice. My name is Micaela Martinez. I'm the Community Resilience Officer at the CEC. And next, I'll turn it over to my colleague Karina, who will also give the instructions in Spanish.
Gracias, Micaela, y bienvenidos a todas las
Thank
personas
you,
que se
Micaela, and
conectaron a este
welcome to
webinario.
all
Mi
the
nombre es Karina
attendees. My
Morales
name
y
is Karina
trabajo en el
Morales, and I
secretariado de la
work at the
Comisión para la
Secretariat of
Cooperación
the
Ambiental.
Commission for
Nos
Environmental
gustaría
Cooperation, and
informarles que
we would like
tendremos
to
interpretación en
inform you that
español,
we will
inglés y
have
francés.
interpretation
Si
in
aún no
Spanish,
escuchan la
English, or
interpretación
French.
en su
If you
idioma,
cannot
pueden
hear
hacer
the
clic en
interpretation
un
in your
icono de
language, you
globo
can
terráqueo en
uh,
un círculo con tres
click
puntos que está
on
en la
the
esquina
global
inferior
icon
derecha
or
de su
the three
pantalla.
dots that
Ahí pueden seleccionar el idioma de su
located on
preferencia.
the bottom of the screen, and there you can select the language of your preference.
Wonderful. Thank you so much, Karina. And now to get us started, we're first going to have an interactive question for the audience. So we're going to pull up our first poll question. And the question is, what is your biggest concern when it comes to wildfires? And you can access the poll via the link in the chat, or you can also use the QR code that is on your screen. And as you answer the poll question, we will start seeing the answers populated. We see one answer for smoke so far. Karina, if you would like to read out some of the answers in Spanish as well.
Gracias. Sí, tenemos una respuesta que es pérdida de biodiversidad.
Loss of biodiversity, that's one answer.
You see loss of homes, toxins, community disruption, animal health.
Tenemos también enfermedades respiratorias,
Respiratory diseases,
Human health, long-term health effects. Housing, air quality, evacuation. Carbon footprint, pollution, and we see biodiversity popping up multiple times. Wonderful. So this looks like quite a diverse set of concerns. And so today we will be hearing from our four speakers who will be actually sharing several information about several of the concerns here, particularly with the emphasis on human health. And so first, we're going to get started with the introduction to why wildfires are becoming such a big issue. And with that, we'll turn it over to Marja Perez. Marja, feel free to unmute yourself and introduce yourself while we pull up your slides.
Okay. Hola, ¿qué tal? Muy buenas tardes
Hello,
para
everyone.
ustedes.
Good afternoon,
Conocidas por acá
everyone.
en
Good
México
morning in
todavía.
Mexico.
Mi nombre es
My name
Marcia
is
Cortina
Marja
Pérez.
Cortina
Soy
Perez.
combatiente de incendios
I am
forestales.
a
Trabajo para la
forest
Comisión
firefighter.
Nacional
I work
Forestal
for
aquí
the
en
National
México.
Commission,
Y bueno, pues el día de
National
hoy
Forest
estoy muy
Commission in
agradecida
Mexico,
de
and
poder
today I'm
compartir un
very
poquito
thankful that
acerca
I'm
de
able to
mi
share
experiencia en
a little bit
incendios
about my
y
experience
bueno,
with
sobre todas las afectaciones que esto conlleva
wildfires and all
a nivel
the
mundial.
impact that this has worldwide.
Creo que está lista.
I think this is ready.
Adelante. Bien. Los incendios forestales, el cambio climático, pues son
Wildfire and
temas muy
climate change
importantes
are
que nos afectan
important
en todo el
topics
mundo.
that affect us
Y bueno,
all
existe
around the
una
world,
relación
and there is
significativa entre todos los
a
eventos
important
meteorológicos
relationship between
extremos
all
y
the
el cambio
extreme
climático.
weather events
A
and
medida
climate
que el
change.
planeta experimenta
As
un
the
aumento
planet
en la temperatura
experiences an
global
increase
debido
in
al
global
incremento de gases
temperature
de
due
efecto
to the
invernadero en la
increase in
atmósfera, los
greenhouse
patrones
gases in the
climáticos
atmosphere,
están cambiando
weather
y esto está influyendo
patterns
en la
are changing,
frecuencia
and this
e
is
intensidad de
influencing
muchos
the
eventos
frequency and
meteorológicos
intensity
extremos
of
en
many
todo el
extreme
mundo.
weather events around the
Siguiente, por
world.
favor.
Next, please.
Fenómenos como sequías
Uh,
prolongadas,
Prolonged
huracanes, nevadas,
droughts,
heladas atípicas,
hurricanes,
tornados, olas de calor,
typical
que si bien
or
son
unusual
fenómenos que están
frost,
presentes
tornadoes,
dentro
and
de
dust
nuestro
storms,
planeta,
even though
con el
they
cambio
are
climático se han
weather
hecho
events with
más
climate
fuertes, se han
change, these
presentado
have
con más
been
intensidad,
more
con
frequent and
mayor
more
afectación.
intense with more damages.
Los incendios forestales son una fuente importante de emisión de dióxido de carbono,
Forest
uno
fires
de
are a
los
major
cuatro
source of carbon
principales
dioxide
que
emissions, one of the
contribuyen al
four main
calentamiento
gases
global.
contributing to global
Uno de los
warming.
mayores retos que
One of the
enfrentamos en el
greatest
planeta es el cambio
challenges we
climático, como
face
todos ya lo
on the
sabemos, y que
planet is
consiste
climate
en las
change, as we all
alteraciones en
know,
el
which
clima global
consists
como
of alteration in the
consecuencia del
global
aumento de
climate
la temperatura
as a
global
result of the increase in
provocado
sea
por
temperature
concentraciones de
caused by
gases de efecto
concentrations of
invernadero en la
greenhouse
atmósfera.
gases in the atmosphere.
Siguiente, por favor.
Next, please.
Esto se asocia
This
principalmente
is
a las
mainly
actividades
associated
humanas,
with
como
human
los procesos
activities such as
industriales, el uso
industrial
indiscriminado de
processes,
combustibles
the
fósiles,
indiscriminate
el
use of fossil
petróleo, gas y sus
fuels,
derivados
oil,
como la
gas, and
gasolina,
their
la
derivatives such
pérdida
as
y quema de
gasoline,
bosques y
and the
demás,
loss and
entre
burning of
otros.
forests and jungles,
Estos
among
ecosistemas
others.
juegan un papel
These
importante en la
ecosystems
mitigación
play
de
an
los
important role
gases de
in
efecto
mitigating
invernadero, ya que
greenhouse
tienen la capacidad
gases
de
as
fijar y
they have the
absorber dióxido
ability
de
to
carbono
naturally
de manera
fix and
natural
absorb
y
carbon
que con ello
dioxide,
regulan el clima.
and
Por
thereby
el contrario,
regulating the
la pérdida
climate.
de estos
On the
bosques pues reduce
contrary,
la
the loss
capacidad
of
de capturar el
forests
carbono
reduces
e
the capacity
incrementa
to
la
capture
absorción de
carbon
calor
and
terrestre.
increases the absorption of of ground heat or terrestrial heat.
Al siguiente, por favor. Por lo tanto, el cambio climático
Therefore,
ha
climate
incrementado el riesgo
change
en
has
incendios,
increased
tanto de
the
manera
risk of
directa
fires,
como
both
indirecta.
directly and
Incluso cuando
indirectly,
la combustión es
even
de
when
origen natural,
combustion is of
por ejemplo,
natural
la presencia
origin,
de
such as the
relámpagos,
presence
las
of lighting.
probabilidades de que
The
dé lugar a un
chances of
incendio de
it
gran magnitud
leading to a
son
large-scale
considerablemente
fire are
más altas
considerably
debido a las
higher
condiciones
due
del
to
clima actual.
current climate
En general,
conditions.
en diferentes
In
lugares del
general, in
mundo,
different
durante las
parts of the
últimas
world
décadas,
over
el
the
área
last few
promedio anual
decades,
devastada
the
por incendios
average
se ha
annual
multiplicado
area
hasta por
devastated
5
by
veces.
fires has
Y todo
increased
esto
up
tiene
to
que ver con
fivefold.
esta
And all
generación de
this
los
has to do
cambios
with
del
the
clima en diferentes
changes,
áreas,
climate
propiciando
changes
pues
in different
mayor
areas,
sequedad en los
resulting
combustibles,
in a
mayor
more
probabilidad de que
dryness in
pueda
the
presentarse un
fuels
incendio
and
forestal.
more likelihood of
La
having
siguiente, por favor.
wildfires.
Particularmente,
In
los incendios
particular,
forestales tienen
forest
muchas
fires have
repercusiones.
many
Estos
repercussions.
incendios no solo
These
representan una
fires
amenaza
not
para
only
la
pose a
biodiversidad y
threat
los
to
ecosistemas, como siempre se
biodiversity
ha
and
manejado,
ecosystems, as
sino que
we
también
all
pueden
know,
tener
but can
impactos
also
negativos en
have
la calidad
negative
del aire y
impact
por ende
on
pues en la
air
salud humana.
quality and human
A
health.
escala mundial
On a
son
global
una
scale,
fuente
they are
importante
a
de emisión
major
de
source
carbono que
of
contribuye
carbon
al
emissions
calentamiento global,
that
debido a que
contribute to
son
global warming,
incendios que
since
se queman en gran
these are
magnitud y pues toda esta liberación
fires that
queda expuesta
involve
al
a
aire,
great
¿no? A la
area,
intemperie
and
para
this is
todos.
exposed
Y
to
bien,
the
pues
air.
con la destrucción de estos
So, with the
ecosistemas o su
destruction
degradación se
or
libera a la atmósfera
degradation
el
of these
carbono que alguna
ecosystems
vez
releases
en ellos
carbon that
estuvo
was once
almacenado.
stored into the atmosphere.
La siguiente, por favor. Bien, En México,
In
el Programa
Mexico,
Nacional de
the
Protección contra
National
Incendios
Forest
Forestales fue
Fire
decretado
Protection
por el
Program
Gobierno
was
Federal en
created by the federal
1972
government in
y a finales del
1972.
2002
At the
fue
end of
transferida a la Comisión
2002,
Nacional
it was
Forestal para su
transferred
operación
to
en el ámbito
the
federal,
National
en coordinación
Forest
con los
Commission,
gobiernos de los
CONAFOR, for
estados y
operation
municipios e
at the
integrado
federal
como
level in
Programa Nacional de
coordination
Fuego,
with state
que
and municipal
contribuye también
governments
a esta
and integrated
participación
as
en la
the National
atención,
Fire
prevención y
Management
manejo de
Program,
incendios forestales.
and this helps manage
Siguiente, por
fires.
favor. Y bien, y a nivel
At
internacional,
the
pues se han
international
tomado
level,
acciones conjuntas de
joint and
colaboración que
collaborative
incluyen el
actions have been
intercambio de
taken, including
conocimientos,
the exchange of
experiencias,
knowledge,
tecnologías, recursos humanos
experiences,
entre diferentes
technologies,
países
and
como
human
México,
resources from
Estados
different
Unidos,
countries such as
Canadá,
Mexico, the
Chile,
United
por
States,
mencionar algunos, entre
Canada, and
otros,
Chile, among
para
others,
fortalecer las
to
capacidades en
strengthen
la atención a los
forest
incendios forestales
firefighting
y disminuir el
capabilities and
impacto
reduce
negativo que
the
estos
negative
causan,
impact
pues
that
a
these
nivel
fires
mundial.
cause
Si bien no
worldwide.
solamente cuando se presenta un
Not
incendio
only when
forestal queda
when there
limitado a
is
las afectaciones a
wildfires,
solamente esa área,
this affects
el
only
dióxido de
the
carbono
area,
que se
but
genera y las repercusiones son
but
a nivel
carbon dioxide
mundial.
that is
Son esta parte de
generated
los incendios que influyen en los gases de
travels
efecto invernadero.
and affects worldwide, especially with the greenhouse gases.
Thank you, Marja, for that wonderful introduction. And next, we will actually have Marja continue to share with us about her work fighting fires as part of the Mexican government. And so as we pull up her next set of slides, I also want to point you to the Q&A section. So please put any of the questions that you have for the speakers in the Q&A section, because we will be asking those questions out to them at the end of their talks when we move to the panel discussion section. Thank you. And Marja, over to you.
Ok. Bien, nuevamente me presento.
So
Buenas
let me
tardes
introduce
para
myself
ustedes. Buenos
again.
días
Good
para acá en México. Mi
afternoon
nombre es Marja
or
Cortina
good
Pérez. Soy
morning. My
un
name
agente de
is
incendios
Marcia Cortina
forestales y
Perez. I
trabajo para
am
la Comisión Nacional
wildfire
Forestal en México.
fighter.
Bien,
I work for
ya
CONAFOR
entrando en
in
materia,
Mexico, which is
les
the
voy a hablar un
National Fire
poquito
Commission.
sobre la
And now
prevención y
I'm
la
going to talk
supresión, que son
about
el enfoque predominante frente a los incendios
prevention
forestales en el
and
mundo.
suppression
Y la pregunta
of
aquí es,
wildfires
¿el
is the main
fuego es el
target.
enemigo
Is a
realmente? Lo
is
vamos a ir
fire the
desarrollando
real
y lo
enemy?
vamos a
And
descubrir
we're
más
going
adelante.
to talk about this during all the presentation.
La siguiente, por favor.
So
Bien, existe esta hipótesis sobre
we
la
have this
mejor manera
hypothesis
de
about the
atender el
best
problema.
way to
Lo
manage
manejamos de esta manera como
wildfires.
el uso del
So
fuego,
we have the use of
ya sea de
fire,
sus causas
whether it's
naturales o el
natural
uso,
causes
mal uso
or
del
the
fuego, ¿no? ¿Y esto qué nos conlleva?
misuse of
Pues a
fire.
a
And
la
this
presencia de
leads
lo que son los
to
incendios forestales que
wildfires.
se van a presentar. Y aquí es el meollo del
And
asunto, la
this is
estrategia de
the main
intervención.
point,
¿Cómo es que
the
nosotros vamos a
intervention. How
manejar
are we going
o
to
vamos a atender estas
manage
conflagraciones que se
or
presentan
combat
y que nos va a llevar de la
fires?
mano
And
directamente
this
a lo
will
que son la
take
toma de
us to
decisiones?
the decision-making
Siguiente, por favor.
process.
Great. Marja, just one quick interruption. For all of the speakers, if you can speak a little bit slowly so that the interpreters can make sure to be able to interpret your words for the rest of the audience.
Ok,
Thank you.
sí, ok, sí. Bien. El fuego ha sido un
Fire
fenómeno
has been
característico de las porciones
a
terrestres de la
phenomenon
biosfera por más de
characteristic of the
400 millones de
biosphere for
años.
over 450 million
Relativamente, pues
years.
nosotros,
Well,
la especie humana moderna, el
the
Homo
modern
sapiens,
human
surgió
species, the
en
Homo
África
sapiens,
hace unos
start,
200.000 años. Entonces,
emerged
el
in
fuego
Africa
es un fenómeno que está
200,000
presente en
years
nuestro
ago. So
planeta,
fire
en
has
nuestro
been
planeta de
present
fuego,
in our
debido
planet,
a que
our
en nuestra
fire planet,
atmósfera vamos a
because in
encontrar
our
las condiciones y en nuestro
atmosphere
planeta
we will
para que
find
surja
the right
la combustión.
conditions
Y
for
recordemos lo
combustion.
que es el
And let's
triángulo del
keep
fuego.
in
En este
mind
caso,
the
pues el
fire
triángulo del fuego
triangle.
está
The,
constituido por lo que
the
son los
triangle is
combustibles,
made
el
up of
oxígeno que está presente en
fuels,
nuestra
the
atmósfera y
oxygen that is
la energía
present
de
in our
activación, el calor.
atmosphere, and
Juntamos
the
estos tres elementos y
energy, the
pues nos va a dar
activation
por ende lo
energy,
que es
which
la
is the heat.
combustión y obviamente
With
grandes
these three
magnitudes pues va a
components,
dar presencia a lo que son los
combustion
incendios
starts,
forestales.
and this leads
Entonces,
to
nosotros no
wildfires.
podemos decir
So
que
we
vamos a
cannot
erradicar el
say
fuego
that we're
completamente
going
de nuestro
to
planeta
uh,
porque es un elemento que ha estado
eliminate
presente
fire from our
conviviendo
planet, because this
con la
is an
humanidad
element has
desde
been
hace
present
pues ya
and
bastante tiempo, ¿no?
and together with the
La siguiente,
humankind.
por favor. Ok. ¿Existen diferencias
Are
entre los
there
incendios
any
forestales
differences
que arden en
between
distintos ecosistemas?
wildfires in
Y creo
different
que esta es una pregunta
ecosystems?
que
And
nos
this is
debemos
a question that we
realizar
have
a la
to
hora que vamos a
ask
atender un incendio
ourselves when
forestal y
we
establecer nuestros
combat
objetivos. ¿Y
wildfires
cómo
and
vamos a
set
diferenciar
forth
todos los
our
incendios forestales? ¿Creemos
goals?
que son
So,
iguales y que
we
solamente se
do
presentan
we believe that
donde tenemos
wildfires are all
bosques,
the
donde hay
same?
pinos? Sin embargo,
Do we
tenemos que
have
ampliar un poquito
wildfires
este
only when we
panorama
can where we can
y
find
tenemos que tomar en
pines or
cuenta que
trees,
existen
for example?
diferentes tipos de
But we have to
ecosistemas que van
consider
a
that there are
reaccionar
different
dependiendo
types of
del fuego, ¿no?
ecosystems that will
¿El que
react
sigue, por favor?
differently.
Ok. Bien, y en esto pues tenemos los ecosistemas que
So
son dependientes al
we
fuego.
have
Y estos
fire-dependent
ecosistemas son
ecosystems, and
aquellos
these
en los que el
ecosystems are
mantenimiento de
those
la variabilidad
in which
natural, su
natural
composición,
variability in its
estructura,
composition,
funcionamiento,
structure,
dependen de un
and
régimen de incendios
functioning
superficiales
depend
de
on
intensidad baja
a
o
frequent
moderada.
fire regime,
La
and these
supresión del
fires
fuego en
are
estos
usually
ecosistemas produce un cambio en la
superficial.
estructura y
So fire
composición,
suppression in
incrementando
these
la carga de
ecosystems produce
combustible que
changes in
aumenta
the
la
structure and
vulnerabilidad a
composition,
incendios más
increasing the
intensos,
fuel
más
load that
severos y
increases the
resistentes al
vulnerability
control,
of fires
debido a
of more
que el
intense and
combustible pues se va
severe
a
and
presentar de mayor
resistant
manera y va a estar disponible.
fires, because
La
this is going
aplicación
to
de
be
quemas
available.
prescritas y quemas de
Prescribed
control es
burns,
una práctica
control
adecuada para
burns
la
is
reducción de
the
riesgos de
right
incendios en este tipo de
practice for
ecosistemas y para
fire
su
risk
conservación.
reduction and for
En
the
el caso, por
conservation,
ejemplo,
for
de
example,
los pinos
of
Hartegill,
the
su
hartagii
cono,
pines.
su
The
semilla
cone, the
necesita la
seed, it
presencia de
needs the
fuego
presence
moderado
of
para que pueda
moderate
liberarla
fire to be
y
able
pues
to
de esta
release it.
manera se
And
puede
this way,
presenta la regeneración en este
we
tipo de
can
ecosistemas, ¿no?
have
De pinos Hartegill,
we can
pinos
regenerate
pátula,
this
ireti.
ecosystem
Esos
with
conos
the
son muy duros y
hartagii,
necesitan la
ireti,
presencia del fuego
pinus, and
para que
they are
puedan
very
liberar esa
hard,
semilla.
and
Y
they
bueno,
need fire to
tenemos
be
otro
able
tipo
to
de
release the
ecosistemas
seed.
dependientes,
We
como lo
have
son los
other
bosques de zonas húmedas y
fire-dependent
subhúmedas,
ecosystems
con
such
sequías
as
estacionales
um,
largas, las
humid
praderas, las sabanas
zones,
y los
forest or
pastizales.
subhumid zones in
La siguiente, por
areas
favor.
such as
Tenemos también los ecosistemas que son independientes del
grasslands,
fuego,
and we
que son
have
aquellos en los que no hay
fire-independent
condiciones
ecosystems.
para la
In these
propagación del
ecosystems,
fuego,
there are no
porque la
conditions
cobertura
for
vegetal es
fire
escasa,
propagation because
discontinua, que no va a
the
permitir que el
vegetation
incendio
is
se propague,
scarce, it's
y debido a
discontinuous
la
and
aridez, las bajas
non-existent, and,
temperaturas, como
and
este
due
tipo de suelo
to
limita al desarrollo
these
de la
arid
vegetación.
conditions and low temperatures, there is
La
the
siguiente, por
soil
favor.
limits fire propagation.
Ok, y tenemos los ecosistemas que
And
son
we
sensibles
have
al fuego.
fire-sensitive
Estos ecosistemas,
ecosystems.
como su
These
nombre lo menciona,
ecosystems,
son
as
aquellos en los que la
you
vegetación
can
no
tell
está
from the
adaptada al
name,
fuego
is
y la presencia de este
an
elemento
area
provoca
that
un
is not
impacto negativo
adapted
de
to
gran magnitud,
fire
como
and
la pérdida de
has
cobertura
a
vegetal
great
y la
effect,
dificultad o
such as the loss
imposibilidad de
of
regeneración.
vegetation
En
and the
México, pues
difficulty
tenemos
or
algunos ejemplos
impossibility
como lo
of
son las selvas
regeneration. We have
altas,
some
medianas, los
examples, such as
manglares, el bosque de
mangroves,
Oyamel, los bosques
high and
mesófilos de
medium
montaña, ¿no? Esos son algunos ejemplos de
jungles,
ecosistemas que son sensibles al fuego, que cuando
OML
se presentan,
forest or
las afectaciones
mesophyll
son muy severas.
forests, and this is where you can find
Siguiente, por
very
favor.
severe effects.
Ok. Entonces nos vamos a hacer esta pregunta.
So
Conociendo
now
ya este tipo de
we are going
ecosistemas
to ask
que
ourselves, now that we
conocemos,
know these
vamos a
different,
ver
that
entonces la
we have
supresión
different
o
types of
manejo del fuego. ¿Cómo es que vamos a
ecosystems.
intervenir
Are
este
we
tipo de
going to
incendios?
manage
Y
or
en la
suppress
supresión, pues
fire?
hace un
In
enfoque
suppression, we have
prácticamente,
to
digámoslo,
focus on
cuadrado.
putting
En la
out
parte en la que
fire,
vamos a apagar el
and
fuego.
we're
A
going
como
to
dé lugar, nosotros tenemos que eliminar el fuego, ¿no?
focus on
Y
eliminating
prácticamente el
fire,
manejo del fuego
and
tiene otro
fire
concepto
management has a different
donde el
concept
conjunto de
in
acciones y
which
procedimientos que tiene
there
por
are a
objeto
series
evaluar,
of
manejar los
procedures
riesgos
that
planteados por el uso del
involve
fuego,
assessing
pero este
and
ya en su
managing
ámbito
fire,
más
but this
amplio,
is in
en
a
el rol
very
ecológico, los
wide
beneficios
scale.
económicos,
The
socioculturales y ambientes en los que la aplicación del
the
fuego es
economic
buena.
issues where fire
Siguiente, por
application
favor.
is good.
tenemos retos y
We
desafíos
have
en la atención de incendios
challenges
forestales porque no
when we
solamente se
combat
presentan ahora
wildfires
ya
because
en lo
not
que son
only
solo
can we see
ecosistemas, ¿no?
this in
Ahora con el
ecosystems,
crecimiento de la mancha
now
urbana,
with
pues ya
the
tenemos la presencia
growth
de lo que
of
son los incendios
as a
forestales
human
en las zonas
settlement, we have
interfaz
an
urbano-forestal,
effect,
donde se
an effect
combinan
on
pues
urban
la
areas where
vegetación,
we
los
can see the
ecosistemas
combination
con
of vegetation,
la mancha
ecosystem,
urbana, ¿no?
and the
Ya sea
urban
rural o
area,
urbano.
whether it's
¿Y qué
rural or
nos va
urban
a
area.
tener como retos y
And what
desafíos?
are
Pues
the
porque requieren la
challenges?
coordinación
We
entre
will need
bomberos
the
estructurales
coordination
y
between
bomberos
structural
forestales o combatientes de incendios
firefighters
forestales
or
y pues son de
wildfire
alta
fighters. And
importancia en la atención
this is
debido
very
a la
important to have. It
mezcla
is very
de
important to
combustibles
have
que se van a estar consumiendo.
coordination because there's going to be
Vamos a
a
encontrar
mix of
ya
different
aunado a la
fuels that will be
vegetación, pues las
combusting,
casas,
and
todo
we have
el
the
material con el que están
households and all
construidos,
of
¿no?
the
Aunado
material,
todo lo que pueda arrasar a su paso.
everything that
Y
can
pues
be
también ahí tenemos otro factor importante
included
que
in the
aparte de
fire.
la
We have
liberación
another
de
example
dióxido
that
de
in
carbono,
addition to
todos
the
estos incendios van a
release of
generar muchas
carbon
más
dioxide,
toxinas y más
all these
partículas que
fires
se van a
will
mezclar
release
y que
more
van a andar
particles
libres
and
por
toxins that will be
pues nuestra
mixed and
atmósfera,
will
¿no?
be released to the
La
atmosphere.
siguiente, por favor. Bien, aterrizando un poquito en incendios
Going
forestales
back
en
a little
México,
bit
la
to
temporada
the
para
forest
este
fires in Mexico,
2025 ha sido una de las más
the
críticas
season for
en la historia
2025
recientemente para México,
season for
colocándose
Mexico
como el
has
segundo
been
más
one of the
crítico
most
en la
critical.
superficie
It has been
cubierta
the
por
most
las llamas.
critical in the surface covered
Se registró un
by
total de
fire.
6.108 incendios en los 32
6,108
entidades
fires were
federativas, con
registered
un impacto de
in 32 federal entities
908.252
with
hectáreas.
908
Esto en el periodo de
108
febrero de enero al 5 de junio del presente año, de
100,252
acuerdo a
hectares.
los
And
registros que
according
tiene la
to
Comisión
the
Nacional
records from
Forestal,
the
de
National
los incendios que se han
Forest Commission,
registrado.
the
Y
fires
bueno,
that have
los
been
estados más
recorded.
afectados
The
fueron
states that
el
have been
estado de
more affected
Chihuahua,
is the
Durango
state
y
of Chihuahua,
Sinaloa, por
Durango,
mencionar algunos de
Sinaloa,
los tres
just
primeros
to mention
lugares,
a few of
con
the first three
afectaciones de
places,
168.320
affecting
hectáreas, ¿no?
more
Entonces,
than
la
100,
superficie y la afectación pues ha
affecting
sido
more than
bastante en comparación y en
908,000
relación con otros años, ¿no? ¿Y a qué
hectares.
vamos con esto?
And
Pues a todas las
what is the
condiciones que
purpose for
genera el
this?
cambio
All the
climático y la
generate
presencia de
everything
cómo se
that is
comportan ahora
generated
ya
by
los
climate
incendios
change
forestales,
and
¿no?
how the forest fires are
La
managed
que sigue, por favor.
nowadays.
Bien, en la atención y manejo de incendios
In
forestales,
management and response to forest
en mi
fires,
experiencia he
in
tenido la
experience, I
oportunidad
have
de
been able
viajar y combatir
to
incendios
work
forestales
and
en
travel
México,
with
Estados
fire
Unidos, Canadá
forest
y
fires
Chile.
in Mexico, United
La
States,
siguiente, por
Canada, and
favor.
Chile.
Ok. Dentro de las actividades
In the
nacionales, pues
national
el hecho
activities,
de que tú vayas a
the fact
combatir
that you are going to
incendios a
be
otros estados,
combating
te abre este
fires in other
panorama para
states,
que tú veas
we have
cómo
this
es que los incendios se
scope
comportan.
and see
Entonces,
how
aquí
the
muestro algunas
fires behave.
fotografías, las voy a
Here we have
ir
some
pasada para que
photographs.
ustedes
I'm
puedan
just going
observar
to
un
show them
poquito del
briefly
trabajo que se
so
realiza
that you can
en
see the
México.
work that Mexico carries out.
Dentro de la siguiente, por favor. Dentro de las
The next, please.
actividades, pues nosotros
In the
vamos en apoyo a
activities,
otros incendios
we
cuando
support other
los
fires.
recursos de los estados se ven rebasados. Se pide el
When
apoyo
the
a otros
resources of the
estados
states
para que
is not
nosotros
good,
vayamos en la atención de incendios. Y bueno, pues es un grupo de
and we respond
combatientes
to other
que están
fires. And
capacitados,
these are
utilizando
people who are
diferentes
trained
herramientas y equipos
using different
especializados
tools.
que se
It's,
enfocan en la atención de incendios prioritarios o de gran importancia. Esta es una fotografía de la
this is
Brigada
a
Nacional
photograph
que estuvo en
of the
operación,
National
donde
Brigade
estuve
that
también
was
trabajando.
operating where I also worked.
La siguiente, por favor.
Next, please.
Me parece que no se ven las diapositivas. Creo que sí. Ok. Bien, para el 2018 tuve la oportunidad de
For
integrarme en
2018,
una
I
brigada
had the
fuerza tipo
opportunity
1.
of
Esto como
working
parte de
with
las
a Type
capacitaciones que
1
también en CONAFOR se realiza.
firefighters, which is called
Estuvimos
hotshots.
integrándonos 4
We
compañeros de México y por
four
primera
members
vez se
from
abrió la
Mexico,
oportunidad para
and
mujeres en
first we
ocupar
had the opportunity.
estas
For the first time,
posiciones.
we had the opportunity of
Estuvimos
women
3
working
meses trabajando
in
en la
these
atención y manejo de cómo
groups
ellos
and
gestionan
how they
y manejan sus
work
incendios
and they
forestales.
manage
Entonces
the
fue una
forest
experiencia
fires.
muy enriquecedora.
This
La
was an
siguiente, por
enriching
favor, donde
experience.
estuvimos
Please, next.
compartiendo
Here you can see how we
conocimientos
shared
de
knowledge
equipo,
in
infraestructura, y en
team, in
estrategias, en
infrastructure, in
tácticas que se
strategies,
llevan a cabo
in
para la
practices that
atención
are
y
carried out
realizando siempre
for the
la seguridad ante todo, ¿no? Que es el primero.
response to
La
forest
siguiente, por
fires.
favor. Ok, ahí son algunas gráficas de donde
These are
estuvimos
some
trabajando.
charts where
La
we
siguiente,
were
por favor.
working.
Para el 2020 estuvimos
For
participando
2020,
nuevamente ya como
we
ayuda humanitaria
participated
en los
once
incendios
again
de
as
California.
humanitarian
Sabemos que este
assistance
año, bueno, este
in
año también
forest
fue
fires in California.
de gran relevancia
It
para
was very
nuestro país
important
vecino,
this year
donde
for
sus
our
recursos
neighboring
también se vieron
country,
rebasados
where
y
the
hay acuerdos
resource,
entre
there are
los
agreements
países
between the
donde se
countries
solicita el
where
recurso.
they are
México
requesting the
respondió de
resource,
manera
and Mexico has
activa y
responded
efectiva,
in a very
atendiendo también
active and
en la
effective
atención de
manner
incendios.
in responding to forest
La
fires.
siguiente, por favor. En 21
In
se dio la,
21,
bueno, tuve la primera participación
I
en despliegue
had the first
internacional en Canadá.
participation,
Esta vez fue en la
international
provincia de
participation in
Ontario,
Canada. It was
y
in
donde esta
Ontario,
vez
Canada,
estuvimos combatiendo los
and
incendios
we
y nos dimos cuenta de
fought
que se
fires,
utilizan
and we
diferentes
noticed that they're
recursos, ¿no?
using
Y
different
en
resources.
la parte en la que nosotros
In
vamos a
the
atender,
site where we are going to
va a
respond,
ser dependiendo de
it
la zona, del
depends on the
ecosistema,
zone,
de
the
todas esas
ecosystem, and
características
all these
específicas que se
characteristics,
tienen en
specific
el lugar y que se
characteristics
le
that
va a
we
dar
have at the
atención.
site and that we're going to respond
La
to.
que sigue, por favor. Igual en el 2023, la
Likewise, in
ayuda humanitaria a
2023,
Chile, donde
humanitarian
también
assistance in Chile,
tuvimos la
where
oportunidad de
we had the
conocer cómo ellos
opportunity
gestionan
of
sus
seeing how
recursos,
they
y
managed their
una de las cosas
resources.
que
And
me
one
llamó
of the
muchísimo la
things
atención
that
fue
surprised
la
me
parte
was the
de
part
su
of
personal,
the
en
personnel,
los que ellos pues obviamente
where
están en
they
entrenamiento, en
are
capacitaciones para mejorar
in training to improve
la seguridad del
the
personal
safety of
que
the
todo combatiente
personnel
tiene que realizar, ¿no?
that every
La
respondent
siguiente,
has
por
to
favor.
carry out.
Y en
And
2023
in
igual tuvimos la
2023,
oportunidad de
we
trabajar en
also had the
Canadá nuevamente,
opportunity of
pero
working
en
in
la
Canada once
provincia de
again,
British Columbia.
but in British
En
Columbia,
estas
Canada.
posiciones, en los despliegues
And
donde estuve
here,
trabajando, realicé la
where I
función
worked,
de
I
jefe de cuadrilla, donde
I
estuvimos
was
trabajando
the
bajo el
head of the
sistema de
team,
comando de incidentes.
and
La siguiente, por favor. Y bueno, recientemente,
recently,
pues para este año fue en el
for
despliegue
this year,
internacional a Canadá
we
nuevamente,
were
pero en
deployed
la
to
provincia
Canada once
de
again
Manitoba,
in
donde
the
estuvimos
province
trabajando
of
por primera
Manitoba.
vez brigadas
We worked for
mexicanas.
the first
Y
time
bueno,
in
esta
Mexican
vez fue una
Brigade,
experiencia
and this
grata
was
porque por
a
primera
very
vez nos
nice
dejaron entrar a
experience
lo que es
for
el ataque
because for the
directo,
first
ya
time
establecidos
they allowed us to
como,
go directly into the
como el
fire,
comando de incidentes en esa
and
estructura.
we were
Y
in
pues
like in the incident
manejamos los
command,
recursos
and
diferentes
we
que hemos estado
managed different
trabajando. Entonces,
resources and
este panorama,
this
el hecho de
scope.
compartir
The
experiencias
fact
entre
that we
los
were able
países
to share
hay a esta
experiences
altura, pues
between the
quiere decir
countries,
que estamos
this
haciendo el
means
trabajo
that
bien, ¿no?
we are doing a
Trabajando con
good job
seguridad y
working
pues
with
apoyando
the
desde nuestra
safety and
trinchera
supporting
un
from
poquito
our
hacia la
work
conservación y
a little
mantenimiento
bit
de
more
todavía de
for the
nuestros recursos que
conservation
aún
of
tenemos.
the resources and
La
protecting the
siguiente, por
resources
favor,
that we still have.
ya casi para concluir.
Okay. Marcia, just in the
Sí,
interest of time, if you
Por
can
cuestión
take
de
one more
tiempo,
minute.
yes, es la última.
Thank you.
Yeah. Bien,
because of time, you only have one
la
more
siguiente,
minute.
por favor. Ok, bien, los incendios forestales manejan un lenguaje
Forest fires
universal,
have
se
a
requieren aplicando
universal
diferentes estrategias y
scope,
tácticas que
and they have
serán
different
guiadas en función de los objetivos
strategies
que se
and
quieran
practices.
realizar. Los incendios forestales
The
nunca se
forest fires
comportarán de la misma
will never
manera, ya
behave
que
in the
las
same
condiciones a
way
las que estos
because the
responden, la
conditions that they
topografía,
respond to,
el
like
flujo atmosférico y el
geography,
combustible, van a
the
ser de manera
the
diferente.
climate will
La
always be
siguiente, por favor.
different.
Y lo único que los
And
hace
the
comunes en
only
toda
thing
esta
that makes them
experiencia que yo he
common in all
tenido
this
durante estos 10
experience
años es
that
pues
I have
que en todos
experienced
los
in these
niveles
10
hay
years is that
afectación.
at every
Esto se
level
genera en
there's
sus
an
diferentes
effect.
directrices,
There are
pérdida de
different
biodiversidad,
guidelines,
pérdidas
loss of
materiales, infraestructuras,
biodiversity,
culturales,
material
pérdidas
damages,
económicas
cultural damages,
y la fuente de contaminación en
financial
todas
or
sus
economic
direcciones y
losses,
la pérdida
and
de
the
la vida
loss of
humana, que creo que es el
human
factor
lives.
principal.
And that's
La
the
siguiente.
main one. That's the main
Y bien, pues como conclusión
issue.
nos enfrentamos a una
As a
realidad de
conclusion,
incendios
we
de
are
tercera
facing
generación
a
y
reality
esto es
of
necesario aplicar
third
tecnologías y recursos que nos
generation
ayuden al
fires,
manejo de
and it is
incendios
necessary
forestales.
to
En
manage
algunos países
forest fires.
estamos
In
aún
some
en esa
countries,
transición de
we
control
are in that
reactivo con la gestión
transition
proactiva.
with
¿A qué quiere
reactive
decir? de pasar de la supresión de
instead of
manejo
being
implica
active.
pasar de un
And that
enfoque
means that
reactivo
we're
al
going
apagar
to
el fuego
in a
solamente
reactive
o a este enfoque
approach,
proactivo de
or this
gestionar el fuego
proactive
para lograr
approach
objetivos
of
de
controlling the
seguridad
fire in
y
order
pues
to
los
have
ecológicos, ¿no?
safety
Entonces, las
and the
responsabilidades de
ecological.
todos,
So the
pues los efectos
responsibility
negativos no
is
son
of
exclusivos
everybody,
solamente de un
and
país,
it's not
sino es un
only
compromiso
the
para la humanidad y
commitment of
para
one
nuestro
country,
planeta.
it's a commitment for humanity and
Muchas
for our
gracias.
planet. Thank you very much.
Thank you so much for that. And please put your questions for Marja in the chat, and she will be answering them later. And next, we would like to turn over to our next speaker, Dr. Colin McCarter. Dr. McCarter, if you'd like to share your slides, and we can turn it over to you.
Second. There we go. Okay. Thank you. It's really nice to be here and to be talking about the kind of our wide range of experiences in fires, and particularly these intersections that revolve around the intersection with fires and human communities and health. And today I'm going to talk about some really kind of cutting edge research that myself and my colleagues, Dr. Sutton, Moore, and Waddington, have been working on over the last kind of year and a half, and really trying to understand what is coming off of our wetland wildfires in terms of toxic metals. But before I begin, I want to acknowledge that this work was conducted on the lands or involving the traditional territories of the Nipissing Anishinaabe, the Atasmekshing Anishinaabe, the Neutral, the Haudenosaunee, the Anishinaabe, and the Yellowknives Dene First Nations. And so, as a researcher in Canada, research chair in climate and environmental change in Canada, up in Nipissing University, so kind of just in the Southern Boreal, I think a lot about pollution and a lot about how humans for centuries have been digging up materials and then burning them and releasing, usually not on purpose, metal toxins to our air, land, and water. And these are metals such as lead, arsenic, mercury, all things that can have really negative or adverse human health outcomes. And you can see from the photos here, they range from industrial revolution and coal burning power plants to the smelters around Sudbury, mostly smelting nickel and copper, to global pollutants that are less localized, like lead pollution. And lead pollution still to this day is negatively impacting millions of people's health worldwide. But peak lead emissions and its subsequent deposition across much of North America and Europe really peaked in the 1970s with leaded gasoline. And in particular, this resulted in a fairly wide range or wide distribution of lead being deposited onto the land surface. Now, since the 1970s, clean air legislation has resulted in relatively much lower lead emissions and deposition, which has really kind of made this a broad contaminant, but at one fixed point in time, more or less. But when you're releasing, hundreds of thousands of tons of lead into the atmosphere through burning fossil fuels, coal burning power plants, and other industrial processes, it goes somewhere. And that somewhere, to me, where it's going is really what I'm interested in as a scientist. And on landscapes, particularly in temperate, boreal, and subarctic and Arctic Canada and North America, it's going into the peatlands. And peatlands are these wet ecosystems that retain water, are usually wet all year round, have a lot of water. Their ground surface is sometimes made up of mosses, sometimes they're forested. But one thing these peatlands all have in common is that they record our collective human toxic legacy of these emissions. And they sequester these pollutants like lead, like mercury, like arsenic within their structure. And they hold on to them, and they do really well at preventing them from being re-released into our environment. Now, peatlands are also important just due to their ability to sequester carbon as well. And so they sequester about 30% of the terrestrial carbon but only make up 3% of the land surface. But it's this sequestration of carbon and metals that make peatlands a particularly challenging environment to work in when we're thinking about metal remobilization due to wildfires. And for those who don't, think about peatlands every day like I do and wake up in the middle of the night to wondering about this question about peatlands, peatlands occur all over the globe. They occur across the northern hemisphere, as well as particularly through the tropical belt and the kind of the equatorial belts in the world. But you can see kind of there's a very large distribution of peatlands through temperate, boreal, and subarctic North America, Europe, and Eurasia. This is also the area where we've had a lot of lead emissions. And so peatlands are so good at holding on to lead, we can actually go out to peatlands, and this is some work done by Osborne and collaborators in 2014, and they did some fantastic work and went out and got peat cores or cores of these wetland soil from all over the world, represented by those black squares there. And everywhere you see a red dot is where they had enriched lead. Or in other words, everywhere there's a red dot, humans have added atmospherically deposited lead into those wetlands and have accumulated over time, typically at a rate much higher than the surrounding forest and grassland ecosystems. In effect, these peatlands that are scattered across the world are our pollution vaults. But these wetlands, these peatlands burn. And that might seem like a mistake in my language. And, how can a wetland burn? But they burn because of that carbon. There's such dense carbon in these peatlands that the fuel density can be that of a tree or higher, leading to when you have really dry conditions, these peatlands burn and they billow out dark, thick smoke. And it's what's within that smoke that really is what concerns me, but also intrigues me. We know that when wetlands, particularly the peatlands, burn, they have negative impacts on air quality as well as human health. And wetlands that burned around Moscow in 2010 roughly resulted in doubling of death rates. And so there's a really clear link between these dark, thick smoke in peatlands and what's in that smoke and adverse human health outcomes. And it's the particulate matter smaller than 2.5 micrometers, that is really the main vector that we look at as scientists to try to ascribe some of these negative health outcomes. But bound on that particulate matter from the burning carbon, the peat, are toxins. And we know that in these peat fire plumes, from some transboundary haze studies done in Southeast Asia, that toxic metal concentrations like lead and chromium are higher than our guidelines in that PM 2.5. But not only that, there's some really good work by a colleague of mine, Sophie Wilkinson, that shows that climate change is increasing the severity and amount of carbon or amount of fire being released from our peatlands. So before we could really understand how much potentially toxic metals are being released from peatlands, we needed to get a good handle on how much carbon was being lost. And that's where we really start. And this work's really being led by Paul Moore or Owen Sutton. But we have developed this nice estimate here. And so this is an estimate of peat smoldering carbon emission losses, or essentially annually how much carbon is being lost from peatlands across the Northern Hemisphere. And this is the SSP 245 is just referring to kind of a moderate climate change scenario. And this is projected out for 2040. And you can see it's kind of all across boreal and subarctic North America, as well as much of Eurasia as well. So when you combine a bunch of different land surface models together and a few different climate projections, you can start to actually get an idea of what peat smoldering losses, or how much carbon is going to be lost out of these peatlands. And the dashed line on this graph here represents the current carbon emissions based on our same modeling routine. And then we have the peat smoldering losses. And so this really smoldering fire is producing a lot of that thick smoke. And we go from a 245 scenario or a moderate climate change scenario to a really severe climate change scenario. And what I really take away from this is that climate change will approximately double peatland wildfire carbon emissions by 2100. And this is due to variations in temperature and precipitation and a bunch of ecohydrological feedbacks that are working within peatlands. So what does this mean for unintended toxins, or things we don't think about often? We don't think about wetland wildfires to be sources of atmospheric toxins. Well, when we start to build the toxin emission into these models, we can estimate then the PM 2.5 lead emissions, and this is in tons per year. And so this is the all northern, the globe. So temperate up to subarctic. And we get this density curve. And so this is all taken into a lot of uncertainty within our model. But essentially, the peak of that curve gives us our median emissions, or average annual emissions, of about 4 metric tons, which is a fair amount of lead coming off of what is only an ecosystem that occupies about 3% of the land surface. What's really important, though, is that per unit area, unaccounted peatland lead emissions are greater than that of all other wetland types. And so when it comes to emitting lead, at least under current climate, peatlands punch above their weight class. They essentially emit a lot more lead per meter squared than forests and grasslands and other types of ecosystems. But our climate isn't stable. We're warming and we're drying, and we're projecting to have increased peatland wildfires. And so when we then layer on climate change into potential lead emissions of these legacy metals, these legacy toxins, we get a very different picture. And so this is a severe warming scenario. And again, PM 2.5 lead emissions in tons per year again. And this 50%, and I'll just say, this really is not kind of outside of what I consider to be kind of fantasy at this point. You know, we're on track, and we're getting to the point where these really warm, severe projections aren't out of the realm of possibility. If we draw a line at the 50% on this graph, is 50% of the cumulative distribution. This gives us our median, or essentially our average, when you factor in all the uncertainties that we have. And when we look at the contemporary emission scenario here in blue, going then out in time under this severe warming scenario, this purples are 2100. What we see is that we have at least a doubling of lead particulate matter emissions across the Northern Hemisphere by 2041 under a moderate emission scenario or climate change scenario, and nearly a 5 times increase by around 2071, 2100 in our most severe warming scenarios. Now, this leads us to this idea of compounding disturbances, because all of these disturbances don't act in isolation. Climate change is operating every day. Wildfires are occurring at the same time droughts are occurring. And they occur in areas where we have economic development. Things we need to fuel, even things to fuel the green transition and batteries. Critical minerals need to be smelted. And so we have economic pressures and economic development and economic disturbances leading to widespread contaminants in landscapes, or essentially what I call pollution bullseye. This is an example of arsenic concentrations around Yellowknife in the Northwest Territories. You can clearly see the soil arsenic concentration bullseyeing around that community due to the historical and legacy smelting in that region. And so we have this intersection with human and community health now. But at the same time, our ecosystem disturbances are re-releasing these toxic legacies across our landscape. And in areas where we have these intersections between wildfires, human health, and economic development, we end up with really an unknown risk of what these legacy metals are doing, how they're emitted, and how might we mitigate or avoid this risk to our human and community health. And so with that, I will end there, and thank you.
Thank you so much for that, Colin. And please remember to drop questions in the Q&A, because we will be having those questions for the speakers at the end of all of the talks. And so next, we would like to turn it over to Dr. Chen. Dr. Chen, if you would like to share your slides, I'll turn it over to you.
Thank you. Okay, so, well, everyone, thank you. It's great honor to be here today to talk about the health impacts of wildfire smoke. So a little self-introduction. My name is Chen Chen, and I am an assistant professor in the Department of Population Health Sciences and Huntsman Cancer Institute and University of Utah. And I'm also an environmental epidemiologist. And my research mostly focuses on the design and application of AP methods to understand how environmental exposures affect population health and equity, especially in the context of climate change. And the environmental exposures I've studied include wildfire smoke. So today, I kind of want to first touch base a little bit on the wildfires of North America in a changing climate, then zoom into the human health impacts of wildfires and related smoke. And then I will touch a little bit on the mitigation and adaptation strategies to protect human health. So across North America, areas burned by wildfire has been increasing. As shown in the blue bars in the first graph, for Canada, the brown bars in the second graph for Mexico, and the green/blue lines in the third graph for United States. So this increasing pattern actually exists globally as well, especially under climate change. And it's also projected to persist in the future. As shown in the figure to the right, researchers have found that as climate change progresses across different severity or different scenarios, the frequency and the length of the wildfire season will keep increase. And this might be due to a few different drivers, including an increase in the atmospheric aridity, or the temperature is getting hotter, which dries out the potential fuels. It could also be related to the change in precipitation regime. So taking California as an example, we're actually projected and we are seeing less and less total rainfall, but with more frequencies, a higher frequency of extreme rainfalls. And such extreme rainfall plus dry precipitation regime actually leads to growth of fuel and a rapid dry out of such fuels, making it more prone to wildfire. And there is also a change in the wind. For example, Southern California, we have Santa Ana wind every fall around September, and which lasts until next winter. And this kind of wind is dry and it comes from the desert and it's really hot. And it could not only dry out the fuel, it could also promote fire spread. So this past winter in Los Angeles, we saw this devastating fire, and one key factor or driver for that fire is the wind. So now we know climate change is, now we know wildfire is an increased risk. So how does that affect health? So we know there is direct impacts from wildfire on health near the fire affected zones, including burns and injuries from the fire, intoxication from carbon dioxide, ozone, and particulate matter. There's also potential eye irritation and reduced visibility that could lead to traffic accidents, and mental illness because people are having traumatic experiences, property loss, and displacement due to the fires. But aside from that, the smoke generated by wildfires can also be transported over a long distance. And this long-distance traveled smoke actually might lead to a higher burden, as large populations will be exposed to wildfire smoke, fine particulate matter, which we call PM 2.5. It's like a major component of the smoke being transported. And as shown in that figure, after the 2023 wildfires in Canada, researchers were studying where did the smoke generated by those wildfires go. And they actually found out that the wildfire smoke generated by the Canadian fire traveled across the globe and contributed to the PM 2.5 concentrations a lot. And aside from that, another important thing is as climate change progresses, we're going to see more and more wildfire. And the PM concentration from wildfire smoke is expected to increase, as shown in the red bar to the right. From 2000 to mid-century and the end of the century, the proportion of PM 2.5 people are projected to experience in Western United States will keep increasing from wildfire will keep increase. So how do we study the health impacts of wildfire smoke? There are a few different methods, and I will talk about two. First, we could study the specific wildfire events using quasi-experimental designs. For example, my colleague led a study that's trying to understand the health impact of the 2023 Canadian wildfires in June, because during the entire month of June, the province of Ontario was covered by smoke plumes coming from the fires. And we actually found that there was an increase in asthmatic-related hospitalizations in Ontario after exposure to such wildfire smoke. There's also other kind of study where we can actually evaluate the overall impact of wildfire smoke. So this would actually require one extra step, which is exposure assessment to quantify the PM 2.5 attributable to the wildfire smoke. And the method to do that could be a dynamic approach where the researchers would model the chemical transport process and quantify the amount of PM attributable to wildfire. It could also be a statistical approach where researchers treat it as a missing data problem and try to quantify or predict the amount of air pollution people would have been exposed without the wildfire. And the difference between that and the observed concentration could be attributed to wildfire. And the end product will be the second figure to the right. Across a space, what is the concentration of PM 2.5 attributable to wildfire? And with all these studies, there are some epi-evidence generated. For example, now we know that wildfire smoke could increase the respiratory mobility, which includes asthma or exacerbation of respiratory infections. There is also evidence linking cardiovascular mobility and premature mortality to exposure to wildfire smoke. And we also identified a few vulnerable populations, including the older populations due to possible higher prevalence of pre-existing conditions, and could also include groups with lower socioeconomic position because they might have less resources to protect themselves against such hazards. And there is also an emergent literature regarding birth and child adverse outcomes coming from exposure to wildfire smoke. But there are quite a few challenges that are still in existence. One thing I want to discuss today are two of those challenges. They are not the only challenges, but I want to focus on them today. The first one is, the first challenge is caused by the episodic nature of wildfire, as well as the increasing trend of wildfire globally. Because wildfire is becoming more frequent, we cannot just treat it as a short event. To some extent, there are areas in the globe where people are exposed to wildfire all summer. They're exposed to such smoke every day. So, however, it's not always at a high level. It has like peaks and flat areas. So that makes us to come up with innovative metrics to study the long-term health impacts of wildfire smoke. For example, researchers have came up with 5 different metrics to capture the frequency, duration, and intensity of wildfire smoke. For example, as we can see in California, if we focus on the last metric, which is the most used, average concentration of wildfire smoke, wildfire PM 2.5 concentration, PM 2.5, we can see Northern California is heavily impacted. But if we look at the second metric, which is actually wildfire PM, daily wildfire PM, a number of days with daily wildfire PM concentration above 0, the distribution is more evenly across the entire state. So we need to really taking these different dimensions of wildfire into consideration when we are trying to understand its long-term health impact. Another challenge is actually originating from the compound exposure to wildfire smoke and other pollutants or climate-related hazards. For example, as shown in the figure here, in 2020, especially during September, about 40% of California area was affected by both extreme heat and wildfire smoke. And being simultaneously exposed to two hazards might have very different or synergistic effect than being exposed to these two hazards separately, because our body might be overburdened by the oxidative stress, and we might not have the capacity to fight against it. So actually, a recent study done by me and my colleagues found that across different definitions for wildfire smoke and extreme heat, whenever these two hazards occur simultaneously, we observed a higher effect in the population than the sum of being exposed to these two hazards separately. This does have some, policy implications, because now that we know there is a synergistic effect, we may have to work harder or prepare earlier to promote early warning alarms for the population so that people know, oh, even though either hazards might be at a lower level, when they occur simultaneously, we need to start taking precautions and protect ourselves even before they get to a higher level, if they were occurring separately. So with that, I want to move on to talk a little bit about potential mitigation adaptation strategies. So one thing people have been proposed for management of fuel is prescribed fire. Which, we want to set the prescribed fires in areas where there's excessive fuel and a time when the wind direction will not bring the smoke to the populous areas. There are studies showing that doing prescribed fire, even though it will also lead to release of air pollutant to the air, it actually has a lower health impact than letting the wildfire occur naturally. However, this is a very, complex process. It's not like we can just, it requires a lot of cooperation and preparation, and it does not solve everything. And another thing people propose is a preemptive de-energization, especially in California, because a lot of wildfires in California were ignited by power line. So they want to take the electricity out of the grid to avoid, especially during extreme fire weathers, to avoid possibility of igniting a fire. But of course, people are impacted when there's no power. And when things like extreme heat occur simultaneously, that's added health risks because people cannot have access to electricity or fans or air conditioning. And of course, there's early warning system to alert people of the coming of the smoke. But sometimes people just cannot really, protect themselves because they don't have access to air purifiers. And then in California, there is this growth of clean air centers where people are trying to provide a safe space where people can take shelters. And of course, there are some individual actions people can take, but similar to the community actions, they're not a one size fits all or a solution to everything. Staying indoor and avoid heavy or prolonged physical activities as example. Not everybody has the luxury to do that. And as a community, we can provide clean air center and help others, but it's an ongoing process and it requires a lot of careful things to find the appropriate solution that works for each individual and each community. And with that, I will thank you and wrap up my talk.
Wonderful. Thank you so much for that, Dr. Chen. And next, we'd like to turn it over to our last speaker, Dr. Michael Schindler. Dr. Schindler, if you would like to share your slides, I hand it over to you. Great. We can see your slides if you'd like to unmute yourself, or I could also unmute you.
Okay, everybody can hear me now?
Yes, perfect.
Perfect, thank you. Okay, so in the previous talks, everybody
Dr.
talked.
Schindler, actually, if you can put your share your screen in presenter view, because right now we could see like the notes and such. So maybe
Oh,
click at the bottom, there should be an icon. If you go back to your PowerPoint. There's an icon on the PowerPoint at the bottom right
Yeah.
once you pull it up.
better?
No, let's
No.
see. There should be show taskbar. If you can just go back to your main PowerPoint.
No,
If you just
because I
open
had
it
two
open it up one more
screens.
time.
It's a Zoom meeting here.
And if we're not able to fix it, it's, oh, yeah, okay. So yes, perfect.
Okay.
Wonderful. Okay, great. Thank you.
Okay, so yeah, my name is Michael Schindler, and I want to talk a little bit about what is actually particulate matter 2.5, so PM 2.5, and how does it actually transport metals. So I'm in the Department of Earth Science at the University of Manitoba. So Manitoba came already up at one of the talks. And so the wildfire smoke you can see here was this summer over Lake Winnipeg. And we had wildfires in the north and in the east of the province. And that is my home school. So now I'm a professor for environmental mineralogy. And so what you may ask, and what I also asked my colleagues who approached me, is what does mineralogy have to do with smoke particles in air? Well, so my colleagues told me, think of smoke as floating particles of the mineral graphite. Okay, so I went to my old lecture notes and looked up, what is graphite? Well, graphite is a black mineral composed of just carbon. And so, well, obviously it cannot be just this mineral carbon or graphite that is floating in air in a wildfire smoke. It must be a component within from the mineral graphite. So let's take a look. What is actually graphite means? What does carbon, how does carbon look like within this mineral? So carbon is here those black atoms, and each carbon is surrounded by 3 other carbon. And this carbon forms 6 rings. And those 6 rings are now arranged in sheets. And those sheets are loosely bounded to the next sheets. And each sheet, which we call graphene layer. And those sheets actually what we will see in wildfire smokes. This component of graphite is this, what we actually breathe in when we are breathing in wildfire smoke. So what those sheets are doing sometimes, it's that they are folding. And they fold like this, and then they form tubes, what we call carbon nanotubes. So it's not just the sheet we are breathing in, sometimes we are breathing in tubes, or sometimes the carbon atoms are basically folding themselves to a ball, which we call bulky ball. And the tubes themselves, you can distinguish between different tubes that have 1 wall or 2 wall, and so on. So this is an electron microscopy image, which we took from those carbon tubes I described, and we recorded this from a wildfire in the Caribbean in Colombia. And so the opening of this tube, as you see here, are 100 nanometers. So now everybody would ask, what is 100 nanometer? What does this mean? It's a totally normal unit for me, but not for everyone. So I have here a slide prepared that actually tells you what it means, so smoke particles. How small are they? What is a nanometer? So scientifically speaking, a nanometer is 10 to the power of minus 9 meter. But this still is just a number. So to better imagine how small actually those particles are that we are breathing in, we have to consider a little dot here. This dot lets to be 1 nanometer. Okay, so then we have here a soccer ball. I'm a soccer fan. And here we have the entire Earth. So we can now pack 1 nanometer dot into a soccer ball in the same number as a soccer ball we can pack into the entire Earth. So imagine how big the Earth is and how many soccer balls you can pack into the entire Earth. This is how many times you can pack 1 nanometer into a soccer ball. So it's a incredible small particle, 1 nanometer. So I give you some idea. For example, a piece of paper, 100,000 nanometer, a human hair, 80,000 nanometer, a DNA, 2.5 nanometer, and a gold atom, 0.3 nanometer. So we are talking about very, very small particles. So this PM 2.5 is correct. It's smaller than 2.5 micrometer, but they're even much, much smaller than 2.5. So the other particles besides those carbon nanotubes are soot particles. And we can learn a lot about soot particles, actually not from studying wildfire smoke. We can learn a lot from coal fire smoke. So coal fires are literally fires that are in the subsurface where coal deposits, especially in the United States, are burning for decades. And they basically emit the smoke and through well-defined cracks, we can literally collect the smoke there. And when we take a look at the smoke, which is a similar smoke than a wildfire smoke, we see that we have here those features. And those little features here, and here I have a 10 nanometer scale bar, those little features are those graphene layers, those graphite layers I showed before. Here are those atoms arranged. And sometimes they form little onion rings. And those soot particles, those are the major component in a wildfire. Now, those soot particles then, we have here an aggregate of soot particles. They're a little bit bigger when they're aggregating to a larger aggregate, but we can still see they have those rounded shapes with an 80 nanometer diameter, and in those spheres, we can actually again see here those little graphite layers. Okay, so we see graphite indeed, or the layers of graphite in soot particles in wildfire smokes, and they're all incredibly small. So the next question I want to address is, how do soot particles and nanotubes actually form in wildfire, right? We have here burning of the soil and so forth. So what happened is, the first thing that we actually create are precursors of those soot particles. Here up are the soot particles, and what we create first is what we call polycyclic aromatic hydrocarbons. Those are literally carbon atoms in rings containing also hydrogen. And those gaseous species, they're still in the gas phase. That's not a solid. They start now colliding. And when they're colliding, they're shedding off the hydrogen, forming the soot particles. But they are really, really, really small, right? So when something becomes really, really small, it gets a much larger area, small surface area. So let's take, we have here a large particle. The surface area is well defined, it's a cube. And now we are splitting up this cube and we make smaller particles. And as you can see, the entire surface area becomes larger. And when we go to even smaller particles, your surface area becomes larger and larger. And a large surface area of a particle means it can interact more with other components. it can take up metals, or it can interact with metals in the atmosphere. So what I show you now are particles, again, from coal fire smokes. But those particles also exist in wildfires. And the large surface area of, for example, those nanotubes shown here allows now those nanotubes to take up metals. In this case, the very toxic metal mercury, right, is taken up, and one can identify actually in between those nanotubes where are the mercury atoms sitting. So that is mercury, a very volatile element. We can go further now and go to another very toxic element, arsenic. And we have here this roundish soot particle. We see here really nicely those graphene layers. And you see nicely how the arsenic atoms are incorporated in between those graphite layers. So we not have also an outer surface that interacts with the atmosphere and metals. We have also an internal surface with the graphite layers, and the internal surface also can take up metals. So all those smoke particles, which you just see as smoke, is composed of very small particles. And within those very small particles, we have actually incorporated toxic metals. So the next thing I want to address is, let's say smoke from wildfire enters a city. In the city, you have also normal particles emitted by urban pollutions, right? So we went to the city of Barranquilla, that is in Colombia, at the northern part, at the Caribbean Sea. And close to Barranquilla, we had wildfires. And the smoke of the wildfires entered now an urban city with lots of industrial activities. And so what we did first is we did a statistic. What are the particles actually composed of that you are breathing in? And so we just looked here at the metals, and because we are at the sea, at the oceans, we see a lot of salt that is attached now to those particles, but we see also metals that zinc, iron, lead, and titanium. And so those wildfire particles interacted with the salt from the ocean, which we call sea spray, and it interacted with the metals that are emitted by urban activities, by industrial activities. So I give you just here two examples. Zinc, for example, is created in urban environments or industrial environments by tire burning, or it is emitted in the atmosphere by tire abrasion. So when you're on a walk along a street which has a high traffic, you presumably will breathe in a lot of zinc particles or zinc in the atmosphere. And so zinc particles now interacted with the wildfire smoke, forming a mixture of wildfire smoke with zinc particles. So the zinc is using then the wildfire smoke particles literally as a Trojan horse from the myth, from the Greek myth, where the Greeks conquered Troy with a Trojan horse. And the Trojan horse is my wildfire particle, and the metals are literally the Greek soldiers that are sitting now on the wildfires. So I want to bring here, give you an outlook, and I want to show you this really interesting paper by Lopez et al. They showed that when you have a wildfire burning in California, you have a lot of chromium bearing rocks in California, and that the non-toxic trivalent chromium, which is in those soils, transforms during a wildfire into the toxic hexavalent chromium. And this is a really proven carcinogenic element. And so my question was, when I read this article, is how many people in California and forest fire fighters in California were exposed to soot particles and carbon nanotubes containing hexavalent chromium? And the answer is, we don't know. So we have a lot of things to do. And I hope I gave you a little bit here an idea how material science and mineralogy can tackle this problem. Thank you.
Great. Thank you so much for that, Dr. Schindler. And I just wanted to do a quick recap because we heard four really fantastic presentations. I think now we have a good understanding of why fires are becoming more frequent in North America, and now understanding the basics of what makes up wildfire smoke and the soot and carbon nanotubes that essentially can act as these Trojan horses for toxic metals. We also learned about the legacy pollution in ecosystems such as peatlands and how toxic metals can be released when these ecosystems burn. And lastly, we also learned about the health implications when it comes to exposure to wildfire smoke. Now, we have about 14 minutes left. So what I want to do is turn over to questions from the audience directed to all of our speakers. And so, Karina, do you want to start with the first question in Spanish? And for our speakers, please feel free to just unmute yourself and answer the question that you're interested in answering. Karina.
Gracias, Micaela. La primera
Thank you,
pregunta
Micaela. The
viene de
first
Ana
question
Prados,
is from
que nos
Ana Prado,
comenta que
and
el
she's
cambio
saying
climático
that
es solo
climate
uno de los
change is
factores a
only
tener
one
en
of the
cuenta si
factors that we
queremos
have to take
reducir
into
el riesgo de
consideration if we
incendios.
want to reduce
Aunque es verdad que
the risk of
aumentan las
fire.
condiciones para incendios, no
So
necesariamente
even though
habrá más
it
desastres si se
increases,
aplican las medidas
it,
preventivas.
it increases forest
¿Podrían
fires,
las y
but
los
if we put
ponentes
preventive
comentar
measures,
sobre estas
we
medidas
can reduce
preventivas y
those
acciones concretas
those
que se
fire
pueden
forest
llevar a
fires?
cabo?
What are the concrete measures that we can carry out in order to prevent forest fires?
I think this is a great question for Marja. If you would like to answer. Sí.
Ok, ¿ahí me escuchan? Tengo problema con el audio, no
I
sé
have
si me llegan a
I have
escuchar.
audio problems. Can you hear me?
Te escuchamos.
Sí, yes.
Ok, bien, respecto a eso,
With regards to that,
si bien el cambio climático sí es
climate
uno de los
change is
indicadores,
one of the
no precisamente que
indicators,
tenga que ver
not
que
precisely that
la
it has
fuente
to
cambió
do
o ya
because it
aumentó la temperatura,
changed
se va a
or
incendiar
because
más.
the temperature
Simplemente
is
va más
increasing, we're going to
enfocado
have more
al
fires.
hecho de que
It
los
is
incendios cuando se
focused on the
presenten
fact that
van
when
a ser más agresivos, más
the
difíciles de
fires are going to
controlar
be more
en
aggressive,
todo
more
su
difficult to
extensión en lo
control
que va
them
de recursos
with regards to
económicos, de
resources,
personal y toda esta
economic
parte.
resources,
Sin
personnel,
embargo,
and all
eso
this
tiene que
part.
ver con las altas
And this has
temperaturas
to
que se
do with the high
presentan.
temperatures
Los
that we
combustibles, pues
have
obviamente van a
in
estar más
fuels. The
disponibles
fuels are
porque
going
van
to
a
be
estar
more
expuestos
available
a más
because they
periodos
are
de
exposed
sequedad
for more
y
periods
tiene
of
todo que ver en esta parte.
drought,
Y dentro de
and
las
it has to
medidas
do with all
preventivas,
this.
pues
With
hablábamos
regards to
en la
preventive
presentación
measures, we
justo
were talking in the
de
first
este manejo de
presentation
fuego que
of
tenemos que
this
empezar a
fire
introducir y a
management
realizar,
that we have
que no todo
to
el fuego es
introduce
malo,
and
¿no? Hay
carry out.
ecosistemas,
Not
como
all
ya
the
lo
fires are
mencionamos,
bad.
que
There are
conviven con el fuego
ecosystems
y
that
que
live
podemos
with the
manejarlos para
forest
que
fires,
la
and we can
afectación
manage them
en el ecosistema
so
no
that
sea
the
de mayor impacto.
effect on the ecosystem doesn't have a greater impact.
Great, thank you so much. And we actually have a couple questions about toxins that we'll ask of Dr. McCarter and Schindler. So we've had a couple concerns raised in the questions about PCBs. Also, one of the questions was with concern regarding legacy pollution, such as PCBs changing into daughter molecules that can be carcinogenic or neurotoxic. Can you speak a little bit more about other toxins that may be of concern in addition to the heavy metals that were discussed today?
I can speak kind of generally. I'm not an organic environmental chemist, and so my handle on those toxins and their transformations, particularly when it comes to wildfires, is much weaker. There are certainly other toxins you are worried about with wildfire, PCBs as well as polyaromatic hydrocarbons, which Dr. Schindler mentioned, are certainly among them, but also you then also have disinfection byproducts, kind of not on the air side, but in the water side. So you can get a lot of high organic matter in the water, and when you go to treat that water, you then get disinfection byproducts. So there are some other contaminants we are concerned about with wildfire, particularly in the intersection of kind of think the boreal and subarctic regions where you have this intersection of really organic soils and communities relying on river water for their water treatment in general. And so it's more than just the atmospheric contaminants out at that. There's also this vector to water and drinking water that I didn't really touch on, but it's certainly part of my research.
Oh, Dr. Schindler, did you want to add anything about other toxins that might be in wildfires, like PCBs?
Well, it's the particles themselves causing harm. And I think there are studies that show that you actually mix wildfire smoke with urban pollutants, you actually create a health effects. But I think that Dr. Chen may know this better than me.
Dr. Chen?
Yeah, so I think there are actually evidence showing, like a lot of air pollutants, there are many sources. Traditionally, it comes from traffic, it comes from industry, and a lot of human activities. But nowadays, with wildfire getting into the picture, one question the environmental AP community are trying to understand is, are the particulate matter or air pollution coming from wildfire more toxic than the traffic and wildfire smoke from, air pollution from other sources? And there are some preliminary evidence showing that wildfire-related air pollutions are more toxic. But of course, how that interacts is like another level of complexity. And it also depends on, where the fires were burned. For example, in Los Angeles, the fire actually burned in the cities, and there are a lot of materials that you're not supposed to be burning were burned, like built materials, and there's a lot of toxic getting released during that time. So that is different from the wildfire that's actually burning in the wild, and then with smoke transported into the city. So it's like a lot of heterogeneity, and a lot of things need to be done for us to truly understand the health impact.
Great, thank you so much. And next, I'll turn it over to Karina to ask another question in Spanish.
Gracias. Tenemos una
Thank you so
pregunta
much. We
de
have a
Sergio
question
González,
from
que le
Sergio
gustaría
González,
compartir
and he would like to
información que
share
reciba con
the
su comunidad.
information he receives
Él
with
dice,
his
¿qué
community.
prevenciones
He
debemos
says,
tener
what
los
precautions should
residentes
residents
que vivimos cerca
who
de los
live near
bosques,
forests
ya que esto
and who
ocurre
regularly experience this
regularmente
every
cada año?
year because this happens on yearly basis? I mean, wildfires happen on yearly basis.
Great, I think Dr. Chen or Marcia, if you would like to take that, one of you.
I mean, like so if it's a community that's living close to fire, I mean, it really depends on exactly where you are. Like what I can provide is health-wise. I would say be very aware of any potential alarms, and sometimes it's just not just the fire that's like right next to you. It could be like something that's slightly more distant, but the wind can carry the smokes to you, and then you should be more careful about what you're exposed to, and adjust your outdoor activities accordingly, and wear masks. I hate when I say like wear masks, because that's like such a restriction to individuals, but sometimes that's what can protect you from the smoke. And also like try to improve the insulation of your home, and maybe use air purifiers. And yeah, so
Thank you. Marcia, did you have anything to add to that about how communities could help protect themselves?
Sí, en este caso mencionábamos ya de la
Well, we
presencia de
can
incendios
already
forestales en esta
mentioned
parte
that there
interfaz
are
urbano-forestal. Y bueno,
wildfires
las medidas
next to
preventivas, en primer
urban
lugar, pues
areas.
serían
So some of
limpiar alrededor
preventive
todas estas
measures are
actividades
to
que
clean
alrededor de las casas, perdón,
around
alrededor de las casas, limpiar de
the
combustibles.
households,
De hecho, hay ciertos
eliminate all
protocolos en
fuels.
algunos
There are
estados donde
certain
ya
protocols in
están
some
implementando
states
esta
in
parte
Mexico
de
where
donde
they
se van
are
a construir
already
asentamientos urbanos,
implementing
ciertas distancias o
certain
límites que tienen que estar las casas
limits or
alejadas
boundaries
de lo que son los bosques o de la
that is
vegetación. Eso sería
especially
como
for
el caso
new
de prevención.
housings,
Y de
that
igual
they have to
ciertos
be
planes en
certain
caso de
meters
que
or
haya un
kilometers away
incendio, qué es lo que
from a
pueden
forest, for
hacer a la
example,
hora de
and
evacuar.
be aware of what
También
you
hay otra
can do
parte importante
if,
que es
if it is
en la
necessary
construcción
to
de
evacuate,
asentamientos,
and
materiales que son
when
resistentes al
uh,
fuego. También es esa parte. Sin
human
embargo, se ha
settlements
estado como trabajando en toda esta
take
implementación
place,
de manera
be
preventiva.
aware that the construction materials should be resistant to fire.
Thank you so much for that. And now we have a question for Dr. McCarter. Are there any nature-based solutions to peatland fires so that we could benefit from the carbon and lead storage and prevent them from being emitted during drought and fire?
Yes, and there's different scales that we have to think about when we're thinking about management and nature-based solutions. And I'll also say this is a very active part of my research, is how do you restore contaminated and degraded peatlands and wetlands? That is the number one thing we can do to limit ignition of these and propagation of the wetland wildfires is restoration. And so, you know, some of the work I've done showed that if you can restore a wetland instead of leaving it drained or impacted by metals, you'd reduce the probability of fire ignition almost 100% in most cases, even under drought conditions. And so that's something locally that you can do at kind of smaller scales, maybe up to the landscape scale when you're looking at maybe 1,000 hectares you need to restore. But when you're looking at some of the vast landscapes that we see in Canada, and particularly, you know, we have these like hotspots of metal contaminated wetlands scattered across the boreal. You know, a lot of what we have to do is really comes down to mitigating and fighting climate change. You know, that's the big thing that we can do to kind of limit these ignitions kind of at the big broad scale rather than just like a local scale. So there's a bit of a two scale thing. One thing's really policy driven. The other is something that we can do, boots on the ground do. So yeah, so restoration is the number one thing to me.
Great, thank you so much for that. And then we'll turn it to Karina for our last question in Spanish, and apologies that we're not able to get to all the questions.
Gracias. Sí,
Thank you
tenemos
so
una
much. Yes, we
pregunta de
do
Marta
have a
Arreola,
question from Marta
que es
Arreola,
para la doctora
and it
Chen,
is for
y
Dr.
pregunta,
Chen,
¿qué
and
protocolo
she's
de
asking
salud
what
que se
health
realice en
protocol
California nos
in
puede recomendar
California
para
can
ciudadanos en
be
Guadalajara,
recommended for
Jalisco, México,
citizens in
en
Guadalajara,
donde hemos
Jalisco,
tenido un
Mexico,
incremento
where we
significativo de
have had
incendios?
a significant increase of wildfires.
Yeah, that's a great question and a hard question to answer, to be honest, because it's such a widespread spectrum of things we can do, ranging from, you know, control of fire, from arranging. It could be like management of fuel, management of potential ignition sources like prescribed fire, or planned power shutdown in California, where the power lines are very old and can easily ignite another wildfire. It could also be the middle, where we actually provide alarms to people, send out alarms to the community, especially those who might not be aware and are super vulnerable to wildfire smokes. And they're also range down to personal level, where we could actually provide, actually it's community level, where we actually, California government has established clean air centers where people can take shelter. Sometimes they are also considering merging it with extreme heat shelters as well. So it's not just providing clean air, it's also providing cooler air. Because one option sometimes people have been using in extreme heat to reduce the temperature is called a swamp air conditioning, where it's increasing exchange of air from outside to inside to reduce the temperature inside. But that could also introduce air pollutants from outside into indoor. And that's something we want to avoid when, you know, extreme heat and wildfire smoke co-occur. Yeah, so there are many measures, and California does have, you know, act as a good example. I just covered a few, and I hope it's of help.
Great. Thank you so much for that. And so now with the very last minute of our webinar, I would like to take this opportunity to thank our speakers for their wonderful presentations and giving their time to us today. I also want to flag for all of you that this is the first in a series of 3 webinars that we have on community resilience this fall. Our next webinar will be later this month, where we're going to talk about toxic chemicals in beauty products, particularly mercury and skin lightening products. And then our last webinar will be covering the impact of the changes in seasonality on communities across North America. So how the changes in our winter and extreme heat in the summer is impacting communities and what we can do about it. I've also dropped in the chat links to a feedback survey. If you enjoyed this webinar, please give us feedback. If you didn't enjoy it, also give us feedback on how we can improve. And thank you all so much for joining us. And once again, really many thanks to our speakers. And we're getting lots of clapping hands and hearts to all of you. So thank you all so much and have a lovely rest of your day. Bye, everybody.